These are examples. I've got two examples here. We'll deal with number 3 from the homework. One of the first things we've got to figure out when we have an inequality is, okay, I already know how to graph these things. I already know how to graph quadratics. Now all I have to do is just deal with the inequality part. So let me grab a pen here and we'll get started. So we'll use red. I got to figure out the axis of symmetry. Now remember that this right here is in vertex form. Okay, so I'm able to get my vertex quite readily. So to go with the axis of symmetry, remember it's an equation, so I always have to start out x equals, because I know that this particular one is opening either up or down. Now by looking at this right here, the -2, which way is this going to open? All right, so if you said down, you were right. All right, so this thing opened down. We know that it opens down because of the fact that we have a -2 out here. So at some point I know I'm going to be turning this way, if you can follow the pen over at the side on the graph. When I go ahead to get the number here for the axis of symmetry, it's going to come from this part here. Now, if we recall, our equations are f of x is equal to a times x minus h squared plus k. So then I'm able to get my value here for the axis of symmetry right out of the equation. So it's going to be the opposite of what I see inside the parentheses. So right now I have that the axis of symmetry is x equals -5. For kicks, let's go ahead and we'll draw this on here right away. Let's see, I need a dashed line. We'll make it red and we'll make sure that it's dashed. And we want arrows on both sides. Okay, so now we go to -5, which is right here, and we're going to draw our line. All right, whoop, there's my axis of symmetry. You just got to straighten it out. It moved as I clicked off of it. There we go. All right, we'll just put it right where it needs to be. Maybe. Come on. Oh, well, I guess we're moving the whole graph. That works fine too. All right, so now my vertex. So my vertex is a point. It's going to be a point that lies on the axis of symmetry. Since I know it lies on this axis, I know that my x is already -5. Not to mention the fact that I know from the equation I can just get the x-coordinate of the vertex and the y-coordinate of the vertex. So -5, -3 is where my vertex is going to be. So I've got to come back -5, down 1, 2, 3, and there's the vertex. Now I know this is going to open down, so there's my vertex. So it's going to come down this way somehow. So I got to get some points. All right, so my advice to you has always been to go from the vertex and be on 2 points either side. Okay, so then in that case, I'm going to have my x value be at -3, -4. This is harder than it looks when trying to write with the mouse. -5, -6, -7. All right, so now I'm going to find what values actually work here. So if I substitute into here, I have to do f of, what are we looking at? -4. Okay, so I'm going to substitute these values in just so I can get points, and in that way I can draw it. So I've got -2 times, in parentheses, -4 plus 5. Then I square that, and I'm going to subtract 3 from whatever I get there. All right, so -4 plus 5 is 1. When I square that, I still get 1. 1 times -2 is -2, and then I still have to deal with this -3, so I get -5. All right, so at this point here at -4, I'm at -5. Might as well finish writing in my vertex while I'm here. All right, so at -4 on the x-axis, I'm down 1, 2, 3, 4, 5. There's another point. Now we know that since I have my axis of symmetry here, I'm going to, on the other side, have a mirroring point. Might as well label my axis while I'm here. That's an X. I should also label my axes. There's Y. There's my X. All right, so now I got that a little cleaned up. Knowing that I have the mirror image on the other side, I can go ahead and write that this is -5. All right, so let's take a look at what does f of -3 look like. So everywhere there was an x, I go ahead and I substitute in. So -2, and then -3 plus 5. I got to still square that, and then subtract 3 at the end. Okay, -3 plus 5, that's going to be 2. And then square that, that's 4. -2 times 4, it's going to be -8, and a -3 more, -11. Now, notice how I only go to -10 on my graph. So really, I got to kind of fake it. Looks like it would be about there and about there. Okay, so now I've got points. I've got enough points to go ahead and then do my graph. Now I got to look up here. See how I have, actually let's choose a different color for this part just so that you can really see a little better. We'll use green. All right. So greater than or equal to, this means I'm going to have to draw my line with a solid graph for coming off of here. Okay, because remember, if it's, and this is not that easy. There we go. Okay, so we're going to, whoops, it doesn't line up too well. There's our curve. Okay, so there's my parabola. Now from here, I got to figure out, do I shade inside or do I shade outside? All right, so I want to choose a point that's not on this parabola anywhere. And actually, one of the best points to choose would be one that is still on my axis of symmetry, because it's going to make my arithmetic easier. So I'm going to choose this point here. Okay, and I'm going to say this is -5, 0. Now this is just for testing to figure out where do I shade. Okay, so the f of -5 is 0. And then I have to see equals -2. I'm not going to have enough room. Hold on, let's erase that. Okay, back to the drawing. Back to the drawing board. All right, so not a lot of room here, but I'm going to have 0 equals -2, then in parentheses, that's a parent, -5 plus 5 more squared -3. And actually, I don't want to use just equals. I need to use my inequality because I'm trying to see if I have a true statement or not. All right, so 0 greater than or equal to. What happens inside here? -5 plus 5, I'm going to get 0. 0 squared is 0. 0 times -2 is still 0. So all this happiness goes away, which is exactly why I chose a point on this axis. Okay, so is 0 larger than -3? Well, the answer to that is yes. Okay, it is greater than -3, so this is true. All right, so now from class the other day, it was a little confusing to figure out, okay, well, when it's true, do I shade, where do I shade? Do I shade inside? Do I shade outside? It's all relative to where this point is. So see how I have the point outside? I substituted that point into the equation or the inequality that I received in the beginning. Okay, so let me get rid of some of this other junk that's in the way now. Okay, so I substituted into the original inequality here. I came out with this point makes this statement true. That means any point that's on that same side of that parabola, that's also true. So my shading, which, let's see, I should be able to get an interesting shading going on here. Yeah, let's use a magic pen just for kicks and see what happens. Okay, that's not a magic pen at all. Okay, so we'll use a highlighter. And we'll choose green. So we shade the area. Whoop, that one went way beyond. We shade the area that's true. So I'm shading all of this. Try to get close to the parabola. Try to fill in most of the spots. Good enough for government work. All right, so now you see that where our shading is, it's everything that's on the outside of the parabola. So that means anything else, yes, I had to get the last little bit, missed a spot, missed a spot, missed a small spot there. Someone will complain because I missed that. Oh no, I can't shade inside the lines. I'm not very good at coloring, as you can see. All right, so based on this, the fact that it's greater than or equal to, first off, the fact that it's equal to is a solid parabola. We then chose a point that was not on the parabola. We chose this one that was out here just because it made the arithmetic easier for me. We ended up with a true statement. That means the point that I chose is part of the solution set. That means that that point is in the shaded area.
It was your cousin's idea. What?
All right, so we got the same kind of thing that we were looking at before. If we go through, and I will change back to normal pens here. So we go regular pen, back to our red. All right, axis of symmetry. So we don't have a value here for A, so then that means it's 1. Okay. Now I look here, I don't have anything added on out here. Well, my axis of symmetry is still going to be x equals, because that's all we're dealing with for these examples. X is equal to the opposite of what I see. So now I know the first part is 2, and then the second part here is 0. Okay, so there's my vertex. So I'm out here at 2, 0. Well, that's kind of nice. I know this is going to open up, so I'll label it that's V there. Might as well label my axes while I'm here. I have my axis of symmetry, so let's go ahead and then draw the line. So we'll go through, we'll put the line in here. And right about there, and I can make a modification to move it right where it needs to be. Okay, so there we are. There's our axis of symmetry. Let's label it using the pen. All right, so here we go. We have x equals 2. That's a very large 2. All right, so now I got to figure out points in the graph. All right, so I want to move 2 points either direction. So then I'm going to want 0, 1, 2, 3, and 4. All right, instead of writing all the equations over here, I'm just going to kind of point up here because it's a small arithmetic problem. So we already know we have 2, 0 is my vertex. Okay, so let's go ahead and substitute 1 in. 1 minus 2, it's going to be negative 1. Negative 1 squared is 1. So we're not moving very far so far. All right, let's put 0 in. So if I substitute a 0 in here, 0 minus 2, that's going to be negative 2. Negative 2 times itself, that's going to be 4. All right, so I should probably go one more, because really I'm only getting as far as here and moving my way up. So we'll put a negative 1 in here, because I want to make sure this is as accurate as possible. All right, so being 2 points away, I'm at 4. Being 2 points away here, I'm at 4. So substitute negative 1 in. Ooh, excuse me. And then we go through, we substitute negative 1 minus 2 is negative 3. Negative 3 squared, then that's going to be 9. And that's far enough. We know it's a mirror image, so I can go ahead and do that. So let's go ahead and put these points in. So at 1, 1, I've got a point. Then at 0, 4, which is my y-intercept, as you can see. And then at negative 1, 9. Now I got a mirror image on the other side. So right there. Nice thing is, I'm just paying attention and seeing, hey, you know what? I'm 1, 2, 3 away that way, so I'm going to be 1, 2, 3 away this way. All right, now I got to take a look at this. This is a strict inequality. It's strictly less than, so therefore it's going to be a dashed line. This is challenge. All right, give me a little leeway here, obviously, since I'm dealing with a mouse and a whiteboard that's only on the computer. All right, so there's my parabola part. Now I got to deal with where do I shade. So again, I'm going to use a green pen just to make it a little bit easier. So I want to choose a point that's on this. Whoops. I want to choose a point that's on here. I guess I'll choose this one. Okay, so I'm at 2, -4. So I substitute in here. So I got -4 less than. If I put a 2 in here, 2 minus 2 is 0. Okay, and then I square it, it's still 0. And then I add 0, I'm still at 0. So is -4 less than 0? Yes. All right, so we got to go ahead and highlight the areas again. We'll use green again, so that means I'm on the outside again. All right, so we'll go through and we'll shade, whoops, everything that's on the outside. All right, so all of this, any point that shows up in this green shaded area, any of this stuff is part of the solution set. All right, I'm not going to get every single spot here. I'm just going to get it close enough so you can get the idea that, all right, so here's what I'm looking at. It's everything on the outside. So that means anything that's out here is part of the solution set. I've just graphed another inequality. All right, I hope this was somewhat helpful. It might be a little long just because of the graphing, but hopefully it's better. All right, thank you, and have a good one. Goodbye.